Okay. Today we are going to start to the block diagram. Block diagram and state variable methods. What is block diagram, Ozan? Yes, it's correct. And so, first of all, at each case, our purpose of this section are given for the what? First of all, the block diagram, just like the Ozan said. Okay, and so this containing to what? Dynamic model. Why dynamic model, Ozan? That's a good answer. Because the dynamic model contains the what? The time-dependent feature, okay? X dot or integral values, okay? And so we need to define these values in terms of what? The algebraic equation, which is equal to the what? The transfer function, right? And so we can connect these blocks into the another one. And so we can solve easily this equation in terms of the what? The S domain. Do you get it? Okay. So TF representation as block diagram and after that the state variable form will be introduced. Zülkü, what is state variable form? Anyone knows that? Yes, but in which form? Yes, we can introduce to any system based on the matrix theory, and so we can convert the, for example, the second order or third order or nth order system into the first order one, in order to utilize the mathematical features, which is called state variable. We have many states to represent the dynamic system, but how we can handle or utilize this feature in a beneficial way, we will learn about it, Ozan. Okay? So, in the first place, we need to head title 5.1, the transfer function and block diagrams. Okay. Up to now, I should write everything because there are some other guys that cannot be coming here, and so we need to note everything. We have dealt with the only equation of motion. Ozan, what is equation of motion? But what is dynamicity or dynamic? Yes, derivative and integral are the what? The main components of the dynamics. If you don't have one, and so we don't have dynamic. This is static equation, right? It's the summary about this. But if we have many systems, there may be many distinct systems. What's the meaning of distinct, Ozan? Yes. Some or parts like For example, we have the motor here, or we have mass spring damper system, just like this one, or we have the sensor. Okay? These three components are the distinct part of the system, which we call it the subsystem. But it is combined in the one main system. And so our purpose is that, for example, driving the mass into the watt, into the specific point. These are the objective. But how we can do that? We need to utilize the motor, we need to utilize the sensor. But these systems are separate because they have own transfer function. How we can combine it? Yes. Yes, yes, thank you. That's all. It's simple. We should combine it. But how we can combine it? In the mathematical theorem, we can write that the dx over dt square plus blah blah blah. Maybe this is the dy dt blah blah blah. Maybe this is the the theta square dt blah blah blah. And so we cannot combine this system to the another one in the time domain. But if we apply the transfer function or the S domain utilization, and so we will have the transfer function, and this transfer function can be used to to combine this system easily or in algebraic way, right? And so the main question is that how can we represent easily in one diagram? This is the objective of the to utilize block diagrams. Okay. In order to do that, we need to return to the return the transfer function, like to for example, the fs can be given in here, and also we have gs and also a xs. Okay. Fs, what's the type of this signal? This is called yes, xs output. And so the gs accumulates to to fs to produce xs. And so just remember the S domain transfer function for a given mass spring damper system, 1 divided by ms square plus cs plus k, right? This is our basic solution for the mass spring damper system, mkc, right? This is the solution. But how we can generate the force in real life? Beyza, how we can generate the force? Bilmen lazım. You should know that. How we can produce the force? Yes, by using motor, right? So, and then we should add another system in here, the motor. This has also a transfer function. But why? Because it has a dynamic. It has own dynamic. And so this generates to what, Ozan? Force or torque, right? And so we can write the GS, this is the mass spring damper system, and so this is the axis. And so which input should be applied to the motor in order to produce the force? Zülküf. Huh? Current, yes, or voltage, right? So we can directly build the relation between the xs with the with the voltage value right now, right? We don't need to calculate the force value because we have two systems in the form of the transfer function, and so we can combine it and we can take or obtain the 1 voltage or the 1 volt affect the system at the end of the output of the XS, for example, 2 or 4 or 5, because we have this dynamic in here, just like this one, okay? Because these are algebraic equation. What's the meaning of the algebraic, Ozan? Yes, this is the algebraic, right? And so we can easily write that this voltage value we as, for example, in that case, 1 divided by S plus 5. This is the what? This is the sample, the arbitrary motor system in the form of the transfer function. Randomly, I select that 1 divided by S plus 5 is given in here. And so this is generates the what? The Fs. And also we have to what? 1 divided by S square plus CS plus K. And also we can generate the XS. And so how we can define the XS divided by VS? How we can build this right now? Yes, it's correct. S plus 5 times S square plus CS plus K. Okay? This is our transfer function. But for a given voltage value. And so we can easily obtain what? The effectiveness. But the effect this voltage on the what? On the XS. With the what? With the 1 transfer function. Just like this one. And so we can analyze this function in terms of what? The roots, right? If we evaluate the roots of this system, and so we can condition it. We can obtain what? The transient or the steady state response based on these characteristics, right? Because in the nature or the real life experiment, you can easily set the voltage value or PWM value or the current value. But you cannot easily set the force value in real life. And so if we are using this transfer function, and so we can easily handle or drive the system position into the what? Into the specific one or the desired one based on this information. Okay? Do you get it? Do you understand what is the advantage of this utilization in here? Could you repeat me? Yes? Yes. What's your name? You. Yes? Abdurrahman. What is the advantage of this utilization? Yes. Okay? Okay. Answer. As always with you, we need to create an example. Suppose that we have liquid system like this one, and so we have a resistance in here or valve, and also we have the pump in here, pump, and so Q in, this is the flow rate, and so also we can put the pressure transducer in here in order to in order to obtain the pressure value of this tank. So how we can draw this system in the block diagram? This is so important because if we can't convert this system, it's coming from the real life, into the into the transfer function or the block diagram, we cannot solve it. How we can write the block diagram of this system? Ozan, could you help me? Q in is the flow rate. Yes. But firstly, I think you need to use or build the GS, the plant, firstly. What is the plant of this system? Plant, in Turkish meaning, it's the sistemin kendisi aslında. Fiziksel sistemin kendisi. Yani fiziksel olan sistem hangisi burada? Plant bu demek. Yes, and so which we call it to the water liquid system, right? Okay, and so we can draw a block, and so this is the physical system, liquid system. Okay, what is the input of this system? Ozan? Yes, Q in. What is the output of this system? Yes, pressure. And so how we can generate the Q in? Yes, pump. Pump. What is the input of this pump? Huh? Yes, or voltage, right? And this is with the volt. See? And so how we can measure this system? This liquid system generates the water pressure value. But how we can sense this or measure this? Huh? Yeah? Yes. But we have the pressure transducer in here, which is equal to the what? The sensor of this system. And so this sensor takes this signal just like this one, and so we can build another block. Pressure transducer. Pressure transducer, okay? And so how we can set or drive this system into the what? Into the specific pressure value or the desired value. And so we need to define the what? The pressure desired in here. Okay? For example, 1 megapascal, right? And so this pressure transducer should be utilized with the what? This is the plus, this is the negative, and so we need to generate the error signal in here. But what is the type of this error? What's the type? This is the pressure desired, right? This is the pressure. Pascal. And so the error, Pascal. But we have the volt in here. We need to convert this Pascal into the volt. How we can do that, Ozan? Just think about it. We need to add another block in here, which is called to the what? No, controller. This is the basic definition of the controller. This controller converts to the what? The pressure value into the voltage one. This is another block diagram or the block for a given diagram. Okay? This is so simple. And so this is the physical representation of the mathematical equation in that case. But we need to turn these equations into the what? Into the transfer function one or the S domain one. And so just build the what? We have liquid system which is coming from the what? The equation of motion. And so we can assign the G to S. This is transfer function. And so what is the output of this value, Ozan? Yes, PS, right? And so we have Q in and QS is assigned in here. And so the pump should be given in the what? This is the G2 and this is the G1S, right? And so what's the input of the G1S? VS, right? And so we have also a controller in here, CS, right? And so what is the input of the CS? Yes. And so we have the what? The plus minus, and so we need to give the what? The P ref S, reference, desired pressure S. But everything must be in the form of the what? S domain. Okay? So, how we can model the pressure transducer in here? Yes. Say it. HS. Okay? And so, just remember, this is the what? The block diagram. In terms of the what? In terms of the what? What's your name? Sarah. In terms of the what? Yes. Why we need to use the S domain? Yes, and so we can generate the what? Our objective is simple. We need to build the what? The PS divided by P ref S, right? This is our objective. And so, if we have the many components in here, just like this one, we have the 1, 2, 3, 4 block. But if we are using the S domain or the transfer function in here, and so we can generate what? The one block to represent the PS divided by P ref S. See, this is huge advantage to define the dynamics in the frequency domain, right? Ozan, do you get it? Okay. And so, how we can do that? We need to copy of these things in here. Yeah. I need to derive the whole equation. So we need to delete this. So we need to write to what? The general transfer function in here. So this is the PS, and so P is equals to the what? E times C times G1 times G2 must be equals to the what? P, right? This is simple, right? Do you get it? The P can be generated to E times C times G1, G2, which is equals to what? The output of the P. And so, what is E? Ozan? Yeah. P ref minus? Huh? No. Huh? Yes. H times P. Okay? S'leri yazmıyorum arkadaşlar. Simple olsun diye. Okay. And so, if we have this equation, and then we can combine these equations, P is equals to the what? P ref times C times G1 times G2 minus HP. H times P times E is removed. C times G1 times G2. Okay? And so we have P and P in here. And so we collect the P terms in here. 1 plus H times C times G1 times G2 times equals to the what? The P ref times C times G1 times G2. Okay? This is simple. And so we have the P ref and we have the P. And so we can write the P s divided by p ref s, which is equals to the what, guys? C times G1 times G2 times 1 plus H C G1 and G2. See? If we give the, for example, the 100 Pascal to this system, and so we can easily calculate to the what? The real P based on this equation. And so we can easily change the G1, G2, or controller, C, or H. These are separate dynamics. But in this form, just see that we combine the whole system into the one equation. Do you get it? And so we can generate what the common characteristic equation in here. And so we can generate what the common roots to the what, to design this system, especially for the time response. Anladın değil mi? Tamam. Okay? Do you get it? This is the huge advantage. So, now, how we can do that? For example, we can build to the what, to the example of the what, to this system fs, okay? And so we have the plus minus term into the what, into the 1 divided by s plus 1, okay? And also we can build the what, the integrator in here, 1 divided by s, and also 1 divided by s. This is the xs, and also we can build the what, the 10, and this is also gives a feedback to the system, okay? And so our basic problem is that the xs to fs must be found, okay, for this system. And so o zaman how we can solve this equation or this block diagram? Which block? This is the xs. This block? Huh. Yes. Okay, and so this is the ES. What is this? This signal. If this is XS, what is this signal? Yes, but this is simple. Firstly, you need to define to the what, to the R signals in here. If this is XS, Ozan, what is this signal? We have the 1 divided by S. Yes, SXS, right? See? This is simple, actually. Okay. First of all, we need to what? To write the XS. XS is equals to the what? Ozan. Say it, Ozan. Yani, you are clever. Could you help me? Yes. Zülküf? Sarah? Yes. Thank you, Sarah. Yes. Yes, 1 divided by S and 1 divided by S, right? This should be interesting because this signal going through to what, to the XS, and so this ES must be multiplied only once with the what? With the blocks. 1 divided by s and 1 divided by s. Okay? This is simple. And so, what is the ES? Sarah. Huh? X. What is the ES? Huh? ES equals to the what? Yes, FS minus XS times this block 1 divided by S plus 1, right? And minus 10. See? This is so simple. That's all. Right? And so we can collect these terms as what the Fs minus Xs 1 divided by S plus 1 plus 10S. Right? See? Okay. And so how we can use this value Es, we need to put into the what? Into this equation, right? So Xs is equals to what? The 1 divided by S square, right? Times Fs minus 1 divided by S square times yes, Xs times S plus 1 10S, right? See, this is so simple. And so if we have this equation and then the Xs can be collected in here just like this one, if we put this equation into the left side, and so 1 plus 1 divided by S square 1 divided by S plus 1 10S, right? Which is equals to the what? The 1 divided by S square times Fs, right? So how we can write the final equation? Just assign this is the what? For example, the G1, this is assigned to G2. It's the arbitrary number. And so the Xs divided by Fs is equals to the what? Just say it. Huh? Yes. And so in the collective form, I solve this equation just like this one. S plus 1 divided by 10 S over 4, 11 S over 3, 11 S square. Okay? If you put the whole equation and simplify it, and so you will reach this equation. Beza. You get it? And so how many roots are included in this system also? Yes, we have 4 roots. And so if we set the specific dynamic based on this information, and so we need to set, or we need to arrange or the change to the what? To this 4th root for the given force value to set the new x value. This is what? This is called the control. If we can change or set the new values of the roots, called to the what? The control theory. Okay? This is so simple.